In this video, we'll discuss the derivative of logarithmic function, right? So this is the last function in the list of elementary function, right? We want to differentiate this function. So this is a function which is inverse to a to x, right? Again, here, how do we do that? We have no idea, right? Everything, the definition is not easy to use, right? We want to use some other things, but we don't know how to differentiate this function, but we do know how to differentiate the exponential function, right? So we change our function to the exponential form. You get a to y equal to x, right? Then you left side is a combination of two functions. Outer function is the exponential function. Inner function is y. We are looking for dy over dx, right? So we just differentiate both sides about x. You get a to y equal to d over dx x, right? And so the right side is 1. Left side, outer function, if you differentiate that, you get a to y times natural log of a here, then times dy over dx, right? So we get dy over dx is 1 over a to y, and also we are assuming a is not 1, right? And so a to y times natural log of a. And again, here we want to change our function to a function of x. We know that a to y is x, so dy over dx is nothing but 1 over x times natural log of a, right? So let me write down the formula here. So d over dx log x with base a is equal to 1 over x times natural log of a, right? So this is also a very important formula we have. Okay. So if you make a to be e, right, then you get d over dx natural log of x, right? Because when a is e, log base a is just natural log. So this is equal to 1 over x because natural log of e is 1. So this is even more important formula we have, right? And so now let's see an example, right? Example on differentiating functions which contains the logarithmic function. Okay, let's see example. Example. And we have y is natural log of x minus plus 2 over root x minus 3, right? We want to find dy over dx. Let's try two different approaches. Our first approach is just differentiate that, right? So we can use chain rule and quotient rule, right? Sum rule, difference rule. So dy over dx is chain rule, right? We know the derivative of natural log is 1 over whatever inside. You get 1 over x plus 2 over root 3 root x minus 3. Now you want to differentiate inner function, right? You want to use quotient rule. You get root 3 root x minus 3 square. Then the derivative numerator, which is 1 time root x minus 3, then minus x plus 2 time the derivative of the second factor, which is 1/2 x to negative 1/2, right? So that's what we have here. Now let's try a different way to do it, right? Remember this logarithmic laws. If you have natural log of a times b, you get natural log of a plus natural log of b, right? Remember, ab has to be positive for sure, right? Natural log of a over b, a a over b, you get natural log of a minus natural log of b, right? Natural log of a to r, this is r times natural log of a, right? So you can change a product or a quotient to a difference. So you don't have to use a quotient or product rule, right? You just use sum or difference rule. And quotient or product rule is a little bit more complicated than quotient, than sum or difference rule. So that's why we want to simplify our function first, right? In this case, our function is basically natural log of x plus 2 minus natural log of root x minus 3, right? So these two are same by apply our logarithmic laws. And so in this case, we can differentiate its new form. So dy over dx is basically 1 over x plus 2 times 1 minus 1 over root x minus 3 times 1/2 x to negative 1/2. This looks way more simpler, right? So sometimes you can simplify your function to then you differentiate. So the process is a bit easier.